Wow! Super sharp images of the Large Magellanic Cloud taken by James Webb. Oh my gosh! How beautiful the space is! Seriously, this is heaven. But wait, what if we don't have advanced technologies? We don't have telescopes. So, for making this amazing space visible to us, thanks to our scientists who are working day and night. As we all know, NASA is one of the best space agencies in the world, and its research has always proven beneficial for the whole world. This time, NASA's James Webb Space Telescope's MIRI has captured a better resolution of the Large Magellanic Cloud than the Spitzer Space Telescope. The wavelength range of the mid-infrared instrument, or MIRI, is 5 to 28 microns. It can see wavelengths far beyond the visible spectrum, allowing it to resolve more details in space. According to NASA, MIRI's sensitive detectors will allow it to see the red-shifted light of distant galaxies, newly forming stars, faintly visible comets, and Kuiper Belt objects. MIRI's camera would provide wide-field, broadband imaging, continuing the astounding astrophotography that has earned Hubble such acclaim. NASA's $10 billion James Webb Space Telescope, or JWST, has all four of its science instruments aligned, as seen in a previous engineering image of the JWST's full field of view. The U.S. Space Agency released a series of images that show Webb's entire field of view. The telescope's four powerful onboard science instruments are capable of capturing crisp, well-focused images. NASA has now examined the same image in greater detail, focusing on JWST's coldest instrument, the Mid-Infrared Instrument, MIRI, or MIRI. While Webb's instruments are still being set up and tested, and full scientific operations are not expected to begin until later this year, the test shot demonstrates Webb's incredible potential to provide clearer, more detailed views of deep space and advance our understanding of galaxies, stars, and our entire universe. But what makes the MIRI image special? The MIRI test image, with a resolution of 7.7 microns, depicts a portion of the Large Magellanic Cloud, a small satellite galaxy of the Milky Way that provided a dense star field to test Webb's efficiency. Previously, NASA's Spitzer Space Telescope's infrared array camera captured an image of the same target at a resolution of 8 microns. NASA compared images captured by instruments aboard two different telescopes of the same object. Webb captured a sharper image of that region of the Large Magellanic Cloud, implying new scientific possibilities. According to NASA's website, the retired Spitzer Space Telescope was one of the great observatories and the first to deliver high-resolution photographs of the near and mid-infrared universe. Webb has a much larger primary mirror and enhanced detectors, allowing the world to see the infrared sky with greater clarity. This will allow for greater clarity and even more innovations. What details does the MIRI image reveal? Webb's MIRI image, for example, depicts interstellar gas in unprecedented detail, with emissions from polycyclic aromatic hydrocarbons, or carbon and hydrogen molecules, that contribute significantly to the thermal balance and chemistry of interstellar gas. According to NASA, once the JWST begins science observations, studies like this one with MIRI will help astronomers gain new insights into the birth of stars and protoplanetary systems. The Webb team has begun the process of configuring and testing Webb's instruments in preparation for science analyses this summer. Webb, the most complex and advanced space observatory ever built, launched into space last Christmas after decades of anticipation. The Hubble Space Telescope's successor, the James Webb Space Telescope, is a large, space-based infrared observatory. The construction of the $10 billion telescopes began in 1996. The Infrared Telescope is the world's largest space observatory and the first of its kind. It was 100 times more effective than Hubble and was folded origami style to fit inside the rocket that launched it. Webb is ready to reveal the universe and usher in a new era of astronomy. The JWST is a joint project of NASA, the European Space Agency, and the Canadian Space Agency. The telescope will represent a giant step forward in our quest to comprehend the universe and its origins. It will investigate every stage of cosmic history, from the first luminous glows following the Big Bang to the creation of galaxies, stars, and planets, as well as the evolution of our own solar system. As we all have been knowing, that James Webb Space Telescope captured a better resolution of the Large Magellanic Cloud, but what is this Magellanic Cloud? If you know, tell me in the comments, and if not, well, let's see. Genuinely, the Magellanic Clouds are something that many northerners never see, so lucky Southern Hemisphere observers get to see them. The Milky Way satellite galaxies are the large and small Magellanic Clouds. They stand out as big, misty blobs of light under dark skies because they are some of the closest galaxies to our own. According to scientists, the small Magellanic Cloud contains approximately 3 billion stars, while the Large Magellanic Cloud contains approximately 30 billion stars. The 15th century Portuguese voyager and astronomer, Ferdinand Magellan, is generally credited with discovering these hazy star clouds, and later on, the clouds were known by his name. However, many early navigators, in addition to Magellan, used these two small galaxies to find their way across the southern oceans. And because they were always visible in the sky to people in the southern hemisphere, they appeared in early southern legends and myths. You must travel south if you want to see the Magellanic Clouds. They are not observable north of 17 degrees latitude. If you live in the southern hemisphere, you can see these satellite galaxies at any time of year because they are south circumpolar, or so close to the south celestial pole that they never set. At about 160,000 light-years away, the Large Magellanic Cloud is one of the closest galaxies to us. It is approximately 40,000 light-years closer to Earth than the Small Magellanic Cloud. The Large Magellanic Cloud is more visible than the Small Magellanic Cloud, but both require dark skies. The magnitude of the Large Magellanic Cloud is 0.9. Keep in mind that it spans an area of sky measuring 9 by 11 degrees. Because of its pinpoint source of light, a star of that magnitude would appear very bright, but the Large Magellanic Cloud's diffuse, spread-out light causes it to appear as a hazy smudge on the sky. The Large Magellanic Cloud can be found in both the Dorado and Mensa constellations. To find it, draw a line from Sirius to the right side of Canopus. The magnitude of the Small Magellanic Clouds is +2. Its brightness is spread across approximately 13 square degrees of sky. It can be found in the southeast corner of Tucana, the Toucan constellation. Tucana the Toucan is well known for housing two amazing deep sky objects that can be seen without the aid of a telescope: the Small Magellanic Cloud and the globular cluster 47 Tucanae. The large and small clouds were known to Australian Aborigines, Maoris of New Zealand, and Polynesians of the South Pacific in the Southern Hemisphere. During their oceanic expeditions, they used them as navigational markers. These hazy star clouds were thought to be wind predictors. Another myth originates in South Africa. The nearby constellation Mensa, or Table, takes its name from Table Mountain in South Africa. According to one legend, the Large Magellanic Cloud is a puff of smoke from a pipe smoking competition held on the mountain. In AD 964, the Persian astronomer Al-Sufi described the Large Magellanic Cloud in his Book of Fixed Stars. He named it Al-Bakir, which means White Ox of Southern Arabia. From Harvard College Observatory in southern Peru, Henrietta Swan Leavitt studied the large and small Magellanic Clouds. She published her work on variable stars in the Small Magellanic Cloud in the early 1900s, famously demonstrating the relationship between the periods or cycles of the star's variability and their luminosities. The title of her study was 1777 Variables in the Magellanic Clouds. The period luminosity relationship was later used by astronomers to solve the riddle of star and galaxy distances. The large and small clouds, astronomers believe, were created around the same time as our Milky Way, 12 to 13 billion years ago. Great galactic tides are thought to have caused their irregular shape as a result of their repeated interaction with our larger Milky Way galaxy. The Dark Energy Survey, which is still ongoing, discovered a dark stream of interacting matter between the large and small Magellanic Clouds. A team of scientists from the University of Arizona conducted simulations that suggested the two galaxies were interacting and might eventually merge. Genuinely, the Large and Small Magellanic Clouds are two of the Milky Way's closest neighbors. They can be seen without the use of binoculars from the southern skies. So guys, that's all for this video. If you have any queries or suggestions in your mind, feel free to put them in the comment box. Also, tell us to know what you think how this telescope is doing. Will it achieve the ultimate goal? Will we be able to know exactly about the past? Or do you think these efforts are futile? Whatever you have in your mind, don't forget to let us know in the comment box. If you like the video, please like, share, and subscribe. And thanks for watching!